Welcome back to the second half of section 10.7. We're going to start off with just looking at testing the endpoints. So let me bring us back here to this problem, this first example we did. Step 3, testing the endpoints. This example that we're about to look at is only considering this step. So someone has already gone through and done step 1 and 2. And so we're just going to look at step 3 of testing the endpoints. So I just want to go through this with you. If you were testing the endpoint x equal -2 for this power series, what test would you use to determine if the series converges or diverges? So what we need to do is plug x equal -2 into that series and see what we get. So we get the sum n equals 1 to infinity, -1 to the n. -2 plus 1 is -1 to the n over n plus 1. So I put -2 in for x. -2 plus 1 is -1. So I have -1 to the n, -1 to the n over n plus 1. Let's simplify. That's -1 to the 2n over n plus 1. But -1 to the 2n is always +1 because 2n is always even. So this is the sum, n equals 1 to infinity of 1 over n plus 1. So the question is, what test would you use to determine if this converges or diverges? Well, I would use the limit comparison test with the divergent p-series 1 over n. Because if you take the looks like approach, this guy looks like 1 over n. And direct comparison isn't going to work very well for that. So I would go ahead and do limit comparison. So that's the answer. I would use limit comparison with 1 over n, and this is why. And then you should go through and actually make sure you can do that test. Use the limit comparison test to show this series diverges. And I have that at the end of the lecture notes. I have a solution. So you might want to pause this video, make sure you can do that test correctly. All right, same question, except now we want to test the endpoint x equals 0. So again, we take x equals 0 and plug it in to that infinite series to see what we get. We get 1 to infinity, -1 to the n, 1 to the n over n plus 1. Now, 1 to the n is 1, so this is the sum, n equals 1 to infinity of -1 to the n over n plus 1. So the question is, what test would you use to see if that converges or diverges? And there's really only one test that seems appropriate, and that would be the AST, because it's an alternating series with un equal to the sequence 1 over n plus 1. All right, so that's the test I would use. I want you to go ahead and show that. Show this converges. And again, the solution is at the end of the lecture notes. So we have diverges at -2, converges at 0. We're going to come back to this example in a second because we're about to find the radius of convergence for this infinite series. And it says do not test the endpoints. The reason why we're not going to test the endpoints is because we did it above. So we're only finding the radius of convergence. So in terms of finding the radius of convergence, you can stop on your flow chart at step 2, because whatever you get for A and B, the radius is going to be half the width of that interval. You don't have to test the endpoints. All right, so I started this out. All right, I'm using the ratio test, and this is going to be limit n goes to infinity. I'm just going to go ahead and simplify as I go. The -1s go away. I'm going to end up with an n plus 1 over n plus 2 And I'm going to end up with the absolute value of x plus 1. That whole thing needs to be an absolute value. You can't separate it out as the absolute value of x times the absolute value of 1, or plus the absolute value of 1. Okay, so that's infinity over infinity here. So we're going to divide top and bottom by n. 1 plus 1 over n, 1 plus 2 over n, times the absolute value of x plus 1. Now, this part goes to 1, so we're just getting the absolute value of x plus 1. So that's step 1. We're in the middle path. Rho is not 0, it's not infinity. It's some number times the absolute value of x, or in this case, this power series is centered at -1. Because it has to look like, this has to look like x minus a, and so that would be x minus -1. All right, but everything goes the same way as the flow chart. I mean, you just have to generalize. So in this case, we're going to take rho and set it less than 1. So we're taking absolute value of x plus 1, setting it less than 1. So we remove the absolute value, -1 less than x plus 1 less than 1. And now subtract 1 from all three sections. -2 less than x less than 0. All right, that's an interval of width 2. So our radius is 1. So you can determine the radius of convergence without ever testing the endpoints. We weren't asked to find the IOC. Had we been asked to find the IOC, we would have to test these two endpoints, which we actually did above, and we found the IOC did not include -2, but is that right? It did not include -2, right, but it did include 0. Okay, so practice 2. Again, here's a power series that is not centered at 0. This one is centered at -7. And then this is the last one I'll do. And practice 3, I put the solution at the end. All right, so 1, we're going to use the ratio test to find rho. Rho is the limit as n goes to infinity of absolute value -1 to the n plus 1, x plus 7 to the n plus 1, over n plus 1, 7 to the n plus 1, all times n 7 to the n over -1 to the n plus 1. Sorry, I found a mistake. This should be n plus 2, because this is the n plus 1th term I have in the beginning, but I already have an n plus 1 here, so if I add another one, I get n plus 2. But all the other exponents are correct. All right, now back over here, I have -1 to the n plus 1, x plus 7 to the n. Okay, that's limit n goes to infinity. The minuses are going to go away. I'll end up with an n over n plus 1 and a 1/7 and an absolute value of x plus 7. Okay, that's infinity over infinity, so I divide top and bottom by n. 1, 1 plus 1 over n. That'll all go to 1. 1/7 absolute value of x plus 7. So when we take the limit, the only thing that's going to live is 1/7 absolute value of x plus 7. Okay, 2. Set rho less than 1, because we're on the middle path. So we've got 1/7 absolute value of x plus 7 less than 1. Multiply by 7, so you isolate the absolute value. And now remove the absolute value. You move over here. Negative 7 less than x plus 7 less than 7. And finally, subtract 7 from all three sections. So negative 14 less than x less than 0. Okay, so whatever my interval of convergence turns out to be, I don't know whether it will include negative 14 and 0 or not, but I do know the radius of convergence is 7, because the width of that interval is 14. So half of 14 is 7. Okay, now I need to check my endpoints. So I'm going to take negative 14, and check that first. So I'm going to plug negative 14 into the original power series to get n equal 1 to infinity, negative 1 to the n plus 1. Negative 14 plus 7 is negative 7. So negative 7 to the n, and that'll be over n 7 to the n. Again, I'd like to cancel those 7 to the n's, but I can't until I separate out the numerator as negative 1 to the n times 7 to the n. So this is negative 1 to the n plus 1, negative 1 to the n, 7 to the n, over n 7 to the n. So now these guys cancel, but I need to clean up that numerator. Okay, I need to add the exponents. So I'm going to end up with a negative 1 to the 2n plus 1 over n. This is not an alternating series, so you could not use the alternating series test. This is actually just negative 1 always on top. 2n plus 1 is always odd. It's going to be 1, 3, 5, 7. And so this is the series negative 1 over n. That's not alternating. In fact, that's negative 1 over n. So that diverges by the p-test because it's not alternating. So diverges by p-test. So negative 14 is not in the IOC. Okay, let's check if x equals 0 is. That was the other endpoint. X equals 0. So you always want to state, notice in my work here, I'm stating which endpoint I'm plugging in. So when I plug in 0 for x, whoops, that starts at 1. Let's go back up here. I get negative 1 to the n plus 1, 7 to the n, over n 7 to the n. So this is a little more straightforward. Those cancel, and I end up with the sum, n equals 1 to infinity, of negative 1 to the n plus 1 over n. That is alternating, because negative 1 to the n plus 1 is going to go plus, minus, plus, minus, plus, minus. So I can use the AST with un equal 1 over n. That's a sequence without the minus sign. Okay. Just a quick checklist of 3 things, and they'll all be true. 1, the limit as n goes to infinity of 1 over n is 0. Check. So in terms of showing your work, you would just show that you checked that, but there's no work to explain there. 2, 1 over n is positive. Check. And 3, the sequence 1 over n is decreasing. Check. So x equals 0 is in the IOC. So our IOC is negative 14 with a parenthesis because that's not in there to 0, but we are including 0. And the radius is 7. Okay, that's it. You can try practice 3 on your own. My suggestion is you use the root test rather than the ratio test. And I've got a solution on there. And if you have trouble, then meet me at that Zoom meeting on Friday and we can talk.